In the next segment, we'll look at schemes we can use to add to our existing infrastructure for information retrieval, but to get additional functionality pretty easily. The first one we'll look at is phrases and proximity with ranking built in. So we saw earlier how we could do phrases and near queries like happy days, but here we want to also consider ranking. So take a query like The Who, which as you may know was the name of a popular band in the 60s and 70s. Both of those terms, the and who, are extremely common, but the combination of the two in order is less common and is kind of interesting. It's got, in some sense, a high inverse document frequency. That's a rare query, the who, relative to the and to who. And so there are lots and lots of matches in our previous scheme, but the ranking quality of the who should be special. And so one idea for allowing these kind of phrase queries to go well is to index phrases, not just terms. For example, we can index all pairs of words that are next to each other in documents. We call these bigrams, or more generally, if you have phrases of length n, they'd be called n-grams. And you basically index individual terms as well as n-grams in your search index, and you rank them with TF-IDF accordingly. You can actually give higher rank if you like to bigram matches artificially if you want them to pop up higher in your search ranking. All right. So more generally, we could do this for terms that are k terms apart. So we can, as we said before, add position to the inverted index to compute how far apart terms are in a document. And then we can use this term proximity to boost the rank of phrases as we go through and compute our dot products for cosine similarity. The idea of n-grams can also be used separately to allow us to do spell fixes, which is something we might want to do before we issue a query to the index. We might actually want to fix any spelling errors in the user's query. So here's the idea of how we do that. We're going to play the same trick we played with n-grams, but instead we're going to play it on letters of words instead of words of documents. And people generally call this using q-grams rather than n-grams for some reason. But here's the basic idea. Create a corpus, like the dictionary, of correctly spelled words. And we're going to build an inverted index on the q-grams of letters of all the correctly spelled words. So we're going to take every word in the dictionary, we're going to bust it out into all its three-letter subsets, and we're going to build a search index on those three-letter subsets. All right? And then when a query comes in, we'll take every word and we'll do a search on that corpus to find the word in the dictionary that is closest to the word that was typed in the query. So here's an example. Consider the word misspelling, which is in the dictionary. That's already been inserted in our index under each of these trigrams, MIS, ISS, SSP, SPE, PEL, ELL, LLI, LAN, and ING. So under any one of those 3 grams, trigrams, you will find the ID of the real word misspelling from the dictionary. Now a query comes into our system and we want to make sure that it's spelled properly. The query is MISPELLING. That's not a correct spelling of the word, right? But what we're going to do is we're going to take that query word, we're going to break it into its trigrams, MIS, ISP, SPE, PEL, etc. And then we'll treat that as a search query, just like the search queries we've had before. It's a 1, 2, 3, 4, 5, 6, 7, 8 word search query. I want words in the dictionary that have all of those, or many of those, q-grams. And that query can be run on our index of q-grams to find near matches via TF-IDF. And guess what? A very near match for that query will be the correct spelling of the word misspelling. And so we can put that term in there and get back a word from the real dictionary that's got many of the same trigrams, and that will give us a real word in the dictionary. We can then fix our query to have the correctly spelled term and then run it over the full document index to find documents that contain the correctly spelled word. Q-grams are really useful in any context where you're trying to do similarity of text at the letter level rather than at the word level. Here are some additional tricks for ranking. One of them is query expansion or suggestions. If someone types in a query, you can, under the covers, add additional terms that you might think are related to the query. And there's many tricks for doing this, both automatic tricks, for example, finding terms that co-occur frequently with a query term, so you could just throw those in. Also human curated tricks. You can have a human lookup table of words that should go with other words so that when a query comes in, you augment the query with those human curated additional words. So query expansion is a very common technique. Sometimes it turns into query suggestions, where in the autocomplete box while you're typing a query, you might get suggestions for additional words that you might want to add to your query. A second thing you can do is document expansion. When you're indexing documents, you can pretend that there's words in the document that aren't really there. One of the most common examples is what's called anchor text. Anchor text is the text in a web link that points to a document. So suppose you have posted a document on the web, and I have posted a link that says, this doc is super cool. The terms super cool may not appear in your document, but because they're in the anchor text of my document, we might add the words super cool to your document when we index it. In other words, under the word super and under the word cool, your document's ID will appear. So anchor text is often used in indexing web documents as a document expansion trick. Another way you can do document expansion is to have an automatic classification algorithm that takes documents in and tries to figure out, for example, what language they're in or whether they have adult words in them or not. And it can add special strings to the document to indicate that these tags exist, that this has been classified as English or Japanese or adult. Basically treat those as magic words that we add to the document. Maybe they have something like English XXXXX, so we have some encoding that's an unusual term. We add that to the document so that in subsequent searches, we can search for things that are in English or search for things that are in Japanese by adding those search terms to queries and looking for documents that have been classified with those tags. Finally, let's keep in mind that not all occurrences are created equal, especially on the web. We might want to mess with the ranking function, like doctermRank, based on features of where a term is used in the document. For example, if the term appears in a fancy font, that probably indicates that it's an important term, and we could boost its doctermRank. If the term appears in the title of the document, that means it's an especially important term for the document, and we can boost its rank, and so on. So we can play games with doctermRank based on things we know about the document that are based on formatting or other issues that deal with the semantics of the document. So these are all tricks that are used in the world to try to boost rankings of terms. And of course, they're tricks that people also use in search engine optimization to try to get their documents to appear high in document search.